We're going to look at systems of equations that have three variables in them. All right, before we do that, I want you to think about a couple of questions. Take a look at this equation, 2x minus 5 is equal to 17, and I want you to ask yourself, would you be able to solve this? Right? And hopefully you said yes, because you already know how to solve something like this. Right? You could just add 5 to both sides, and then divide both sides by 2, and after doing all that, you would get x is equal to 11. Right? So you've got an equation with one variable, no problem, you guys know how to solve that. Well, what about this? Would you be able to solve this? 4x minus 3y is equal to 16. Right? And the answer is not really. Right? If we were looking for a single solution, a single value for x and a single value for y, we wouldn't be able to solve this. Right? Because we wouldn't be able to solve for x unless we know what the value of y is. Right? And vice versa. We wouldn't really be able to figure out the exact value of y if we didn't know what x was. Right? So there's not enough information to solve this and get a single answer. If you want to solve this and get a single answer, you need to have two equations. You would need to have what we've been talking about, a system of equations like this. Right? So in order to solve for two variables, you would need to have two unique equations with two variables in it. Right? And we've been working on things like this. We've been using techniques such as substitution, elimination, and graphing. And it turns out for this one, if you were to solve it, you would get an x value of 1 and a y value of negative 4. Right? And of course, we've also talked about how we can represent that as an ordered pair, 1 comma negative 4. Right? What about this now? What if we wanted to solve for three variables? If I had this equation, 4x minus y plus z is equal to 9. Would you be able to do that? Right? And you've probably figured it out. No, you wouldn't be able to, because if I really want to get a single value for x, I really can't do that because I don't know what y is and I don't know what z is. Right? And if I wanted to find out what y is, I really can't do that because I don't know what x is and what z is. Right? So there's not enough information. Well, how much information do we need? To solve for three variables, what we need is a system that has three equations. We need a system that looks like this. Okay? So in order to solve for three variables, we need to have a system that has three unique equations like this. Right? And I'll go ahead and tell you the answer. We'll talk about how to find the answers to these in a little bit. But right now I'm just going to go ahead and tell you that the answer to this problem is you get an x value of 3, a y value of 2, and a z value of negative 1. Right? And you can represent that answer in something we call an ordered triple. Right? It's not an ordered pair, it's an ordered triple. Right? And when you write an ordered triple, you write your x value, comma, your y value, and then your z value. Right? So this answer could be represented like this. 3, comma, 2, comma, negative 1. That would be the ordered triple. This is our solution. The x value, the y value, and the z value. All right, so what does that mean, that this here is the solution of this system? Right? Well, think about this word. We've been talking about this word a lot, solution. Right? That means that this ordered triple satisfies all three of the equations in the system. In other words, if I were to substitute 3, 2, and negative 1 in for x, y, and z in all three of these equations, they would all result in a true statement. Right? So let's say you have this problem and you want to show this. You want to verify that this point here is this ordered triple is a solution of this. Well, just like with two equations, we have to show that that point satisfies our equations. Right? So let me label these. Let's call the top one equation A, the second one equation B, and the third one equation C. Right? Just for reference. All right. So let's do equation A. All right. Let me verify that 3, 2, negative 1. That's the ordered triple that satisfies that equation. Right. So simply let's go ahead and do our substitution. So 4 times my x value minus my y value plus the z value should be equal to 9 if it's truly a solution. Right? Let's go ahead and plug it in. So my x value was 3, y value was 2, z-value is -1. Let's see if this works. So this is 12 minus 2 minus 1 equals 9. And yes, we get 9 equals 9. That is true. Right? But remember, that's not enough to prove that this is a solution, right? Because if this is a solution of the system, it has to satisfy not only equation A, but also equation B and equation C. I want you to pause the video right now. I've done equation A. I want you to go ahead and prove that 3, 2, -1 also satisfies B and C. Go ahead and pause and do that. Alright, welcome back. Alright, let's double check and make sure that it works in those two equations. Alright, so we already did equation A. Let's do equation B over here. Alright, so equation B is 3 times our x value minus 2 times our y value minus 5 times z should be equal to 10. Alright, let's check to see if that works. Well, let's plug in our x value of 3, and let's replace y with 2 and our z value with -1. Let's see what we get. This is 9 minus 4 plus 5 equals 10. Alright, and 9 minus 4 is 5 plus 5 is 10. So we do get 10 equals 10, which is true. So it has satisfied two equations so far. Will it satisfy our third? Alright, let's go over, find some space. Let's do C over here. Equation C is -2 times our x value plus our y value minus 4 times our z value, and that should be equal to, that should be equal to 0. Alright, so let's go ahead and plug in 3 for my x, my y value is 2, and my z value is -1. So we have -6 plus 2 plus 4, that should be equal to 0, and yes, that's true. 0 is equal to 0, that is true. Okay, so again, what have we done? Right? We have demonstrated that 3, 2, -1 satisfies all three equations. Right? And because it satisfies all three equations, that means it's the solution of our system. Alright, so just real quickly want to say a couple other things. What does it mean, or what does this look like visually? Right? So when you have three equations with three variables, right, we're no longer dealing with 2 dimensions, we're dealing with 3 dimensions. Right? Here's kind of a little picture so you can kind of get a visual picture of what this would look like. Right? So we don't have just 2 axes anymore, we've got 3. This is 3 dimensions. So you see this would be like the x-axis, the y-axis, and the z-axis. Right? So not just in 2D, this is in 3D. So what does it mean when I say that, what does it mean graphically when I say that the solution to our system is the ordered triple 3, 2, -1? Right? Well, these are not lines, these are planes. If you were to graph them in 3 dimensions, they are planes. Right? So it'd be something kind of like this. This is not the exact graph, but it'd be 3 planes that intersect at a single point in the three-dimensional coordinate system. All right. So that's kind of a visual picture of what this means. And in our other video, we'll talk about how we can solve these.